So we've looked at integration for a bit, and you've been doing calculus for a while now. And the foundation of calculus is rates of change or differentials. So your goal today is to use implicit differentiation. Do you guys know what implicit means? Third, not direct. That sounds like a good definition. Not direct. In the past, we've looked at an equation. Usually your equation is like y equals something. And it's very explicit how to differentiate it. Good. So now we're doing implicit differentiation. So you have, for example, I don't know, an equation that looks like this. So the equation is not y equals x or something in terms of x. So what's logically the first step that comes to mind? Rearrange it, yes. And then we've changed it from implicit to explicit. We've got y by itself. But we don't have to do that. And that's what today's lesson is about. Sometimes it's difficult to rearrange an equation. So you don't have to do that. So let's have a look at this, shall we? So there's, like this question, you could rearrange it. We could call that method 1. So we could rearrange this to determine the derivative. So you bring the x over to the other side and you square root. It is the difference of two squares, very good. And now we can do dy dx. We have the chain rule, squared equal u. Oh, that's right, dy du, thank you. There we go. So chain rule, the negative 2x, what's the derivative of u square root? So a half u. So the 2 and the half cancel out, and you can sub what u is back in. So you're left with, bring that under the fraction. Does that make sense? So that's dy dx 2. And let's find the rate of change of each of these parts in terms of dx. The rate of change of x squared in terms of x is 2x. So bring the power at the front. Let's come back to the middle one. The rate of change of a constant. Now we have the rate of change of y squared. Again, this is where we can use the chain rule. Correct. So let's let u equal y squared. So du dx, which is this, equal du dx is du dy times dy dx, or the rate of change of the inside times the rate of change of the outside. Do you remember chain rule? 2y, very good. It's the rate of change of y in terms of dx. We don't know. That's what we're trying to find out. So now we can sub that in, 2y dy dx, and we can rearrange this to get dy dx by itself. Bring the negative 2x over, and then divide by 2y. So you're left with negative x over y. So that is a different method compared to rearranging. The new thing is this part here, and letting u equal to that, and using the chain rule. I guess it's in a unique way or a different way of thinking. They should be the same answer though. If you look back here, I'll use a different color. This is equal to this. So, oh, and that as well. So you're left with negative x over y. Yeah, you can do either method. That's why I showed you both. But what I obviously didn't emphasize it enough. Sometimes you can't rearrange, like it's too hard. So you have to use this unique chain rule. So we can get the x part, but it's currently being multiplied by a y. So what do you think we should do? Which is called the product rule. U times the derivative of v plus v times the derivative of u. So if, I guess we don't really need. Does that answer make sense to everyone? Because if it doesn't, speak up. It's going to get harder. So I used the product rule, and I wanted to find that differentiation. So it's that times that and that times that.